Okay, hi guys. Welcome to the AD7LN radio room once again. And today I'm going to talk to you a little bit about a subject that really isn't part of ham radio, but it is radio. And it does affect ham radio. And it's rather unique. There are some people that find this part of the radio section their own hobby. And we'll get into that in a little bit more depth. So the radios that I have here on the table are two of the radios that I have built for this specific part of that hobby. And I'll get into those in just a bit. So stay tuned, and this should be a different one. Okay, what we have here on the table that I'm showing are my two of 3 or 4 radios that I have built. They're VLF, ELF receivers. Actually, I think this was the first one that I built that is variable. It has an actual RF gain on it, and shows the status of the signal input. And this also has not only the electrical receive of VLF, ELF, but I also have a magnetic receiver that indicates on these two LEDs in the event of local lightning that goes off. These transfer from one color to the next. Both these radios require a very large, long antenna and very good grounding. There's a ground lug on the back here. This particular one is my carry around to go out in the middle of nowhere and operate it. Has an SO239 connector on the top so that you can put a tall antenna on it. Also has a ground on the back so that you can stick a ground stake into the ground. These radios, because they're so low in frequency, they are susceptible to 60 hertz hum from power mains, so you have to be far enough away from civilization so that you can appreciate everything that these radios receive. The radios are designed so that there is a receiver, a filter, to try to filter out some of the unwanted noise, and then an audio amplifier, a very clean audio amplifier that will go to this, which is a little speaker box that I've put together that seems to be very, very sensitive to the audio input of these small amplifiers that these two radios have. So let's talk a little bit more about what these radios do and what they receive and why. It's actually quite different and kind of fun. Okay, starting off here, as you can see, here is the United States frequency allocations from basically DC to daylight, or right before daylight. Hundreds upon hundreds, thousands probably, different allocated frequencies. But if you look at the top section, closer towards the left top, you'll see that there's very little going on the radio frequencies up there. So let's point our attention more towards those less allocated frequencies. And starting off here, we see a regular chart just showing the electromagnetic radio spectrum from ELF all the way up to EHF. And for those that are into ham radio or shortwave, immediately you should recognize the HF portion, 3 megahertz to 30 megahertz. And also same applies for scanner operators and ham radio operators, the VHF section, 30 megahertz to 300 meg. And those that are over in Europe for long wave, 30 kilohertz to 300 kilohertz. Long wave really doesn't get used much over here in the United States, other than for aircraft beacons. But anyway, let's point our concern and attention towards the ELF to VLF part of the spectrum, way below long wave, way below medium wave, from 3 hertz all the way up to 30 kilohertz. And most of the things heard over a VLF radio will be heard between the ULF and VLF bands from 300 hertz to 30 kilohertz. That's where most spherics are heard. Spherics meaning the natural made radio noises. So let's start off with what is VLF radio. Sometimes called natural radio, it is a wideband receiver capable of around 300 hertz to 30 kilohertz. What does it receive? It receives naturally occurring electromagnetic emissions from Earth due to certain factors that affect the Earth's magnetosphere. And not only the magnetosphere, but electrically charged cloud-to-cloud activity, cloud-to-ground lightning activity, but as far as the Earth's magnetosphere, I don't know if you've ever done this as a child or in school as a kid, but you get yourself a bar magnet, put a piece of paper over it, and sprinkle filings, iron filings over the paper. And it shows the magnetic lines that are produced by that bar magnet. Well, the same thing kind of applies with Earth itself. Earth has those magnetic lines running north to south, just more of them, and it's called the magnetosphere. And that magnetosphere has a lot to deal with what's going on with VLF radio. So, what spherics are received? The most common heard in the VLF range 24/7 is lightning. The sounds made are similar to popcorn popping or glass breaking. The lightning crashes can be heard all around the world from a VLF radio due to the low 0.1 to 10 kilohertz frequency that's emitted. Earth gets struck 100 times a second by lightning, so you can imagine that there's a lot of activity on these VLF radios once you turn them on. Another interesting spheric is called tweaks. These are heard mainly at night because of the atmospheric path. These can be caused by abrupt disturbances in the magnetosphere. Meteor showers into Earth produce these tweaks. The sound is similar to a rock being thrown at a cyclone fence. Whistlers. Whistlers are a distinct descending whistling sound created by a lightning burst that travels up into the magnetosphere and overcharges one of those magnetospheric lines. The charged particles will travel within the magnetospheric line until the charge decreases and fizzles out. The sound will echo as the charge is decreasing. Red sprites and blue jets are most likely the cause of whistlers. The dawn chorus is heard usually in the morning as the sun starts to rise and charges the magnetosphere above you. Chirps and or multiple rising tones will be heard. That's what a dawn chorus would sound like. Now, man-made VLF? Well, there is a little bit. Mainly Russian ship navigation. The United States Navy does have some sort of communication system on VLF, most likely for submarines. And then over in Sweden, there's what's called an SAQ radio station. And they transmit Morse code only twice a year. I believe that's on Christmas and on 4th of July or something like that. Takes a tremendous amount of power, and most of that transmitted power gets absorbed into the earth. However, what minute amount of power does get via RF radio waves above the Earth's surface, because of its low frequency, that radio signal will travel basically around the world. Hams have dabbled with the VLF frequencies. However, it's very difficult to transmit voice in the VLF range, only because it's such a low frequency with so much noise going on. Transmissions have been done by ham radio operators through digital modes, but it's still a basic work in progress. Many people around the world find this VLF, ULF, ELF radio receiving a hobby, and they take great pride in their hobby, just as someone would for shortwave listening or ham radio operating. I've found some of these VLF hobbyists on social media, and it's quite interesting to watch and learn from them. what they're receiving and why and what have you. But anyway, I've given you guys a bunch of information, not all of the information involved, but enough to get you people started and possibly get you interested so that you can read more about natural radio, VLF radio. And I hope you enjoy. So that about does it for the VLF ELF radio session for today. Hope you enjoyed some of it, or at least got you interested in some part of the radio hobby that these other people have. I did it just through pure fascination to hear all the spherics that were out there firsthand. So that's why I built these radios. If you people are interested, I may be able to dig up the schematics for these radios. I did these many, many years ago, but I still may have the schematics to these circuits. So let me know in the comments below if you want to see a more in-depth VLF, ELF session. So with that, I'll let you go. You have a great day, and thanks a lot. This is Alpha Delta 7 Lima November, and I'm clear. Bye.